Hey everybody, my name is Luke Fuhrer. I'm a precision ag engineer with the Digital Ag Innovation Lab, and today we're going to be talking through what are the best practices for drone applications for fungicides. As we understand, especially as we saw this past season, I feel sure more and more folks were going down the road and seeing these drones up in the air, putting out various applications in season. So we understand what are the best practices surrounding these applications going forward. Just that way we make sure we're on top of this, making sure we're doing a good job. It's definitely a big thing we like to focus on is doing a good job in each of these applications. So, of course, we've now seen drones around the marketplace or around agriculture now for a few years, but our friends over the FAA decided to go ahead and put together this forecast. As you can see, it says 2025 to 2045, and what that looked like. So you can kind of see all the way back in 2021, not very many drones were registered. These large UAS platforms were not registered with the FAA. Really, this was, we understand this is a new emerging technology. But however, we begin to see that graph slowly start to creep up. So this would have been data that had come out of 2024. So as you can see there, roughly 5,000 large UAS aircrafts are registered with the FAA there in 2024. Now that we've wrapped up 2025, I feel sure they're going to start going out, putting in numbers for what 2025's registrations look like. I haven't seen those quite yet, but you can begin to see this projection as we see this, it's getting bigger. As I kind of, we'll go ahead and jump to that bottom bullet there. It says agriculture spray drones are here. They're here, and I'll be honest with you, they're likely here to stay. And I'm really excited about this. I will admit, I'll be the first one to admit it. I was a little bit skeptical going in to the start of the use of these platforms. Again, we didn't know as much about these. We're really familiar with big iron, red iron, green iron, things like that. We're very familiar with those. These new platforms are something brand new. We're still learning about them, and we're definitely innovating these at a much faster pace sometimes than we can some of these large traditional manufactured equipment for agriculture. With that being said, kind of we'll jump back to that middle bullet that says, as it says in July of 2025, just shy of 500,000 total commercial drones are registered with the FAA. So, of course, that's going to then include large and small UAS systems. So, again, UAS, UAV, drones, all kind of continuing to be the same thing, just different naming. But with that being said, just shy of 500,000 were registered with the FAA. So we understand that the drones are here. Like I said, they're here to likely stay. I think they're going to be a really useful tool. They're going to be another tool in our tool belt, or another tool in our tool bag each year as we go through these agricultural seasons. I'm really excited also just to see where this is going. The other thing, of course, you begin to see in that graph itself, especially pay attention to that kind of lighter blue color there where it says added with the P being that's your predictions. The FA, you begin to see that area of blue is growing each year. So we're beginning to see more and more. They're predicting more and more people are getting into the large UAS space. So again, like I said, reiterating it for the third time, just even on this slide, they're here and they're likely here to stay. With that, let's walk back in time a little bit. 2025, DJI, it's definitely probably a name most of you all have heard. They're pretty prominent around both the small and large UAS marketplace and landscape. Back in 2025, they released their Agris MG1. Wow, this was a big deal. We finally were able to put a tank on one of these larger drones and make applications in the field at a commercial opportunity here in the US. As it says, 2.6 gallon liquid tank, four hydraulic nozzles. So that's going to be those standard nozzles that we see on any ground sprayer. Then 27 mile per hour max speed and a whopping 56 pounds of max takeoff weight. Okay. So again, this was new. This was innovative. This was exciting for us to see. And then 10 short years later, DJI released their T100. So this past year, they released this T100, and what a behemoth it is. 26.4 gallons of liquid spraying. Oh my goodness. I mean, a full decimal place moving when it comes to the size of that tank. We're now going from our traditional hydraulic nozzles to now it comes in a 2 or 4 rotary atomizer configuration, depending upon what you need or what you want. As it says there, the maximum flow rates being 30 to 60 gallons per minute, respectively. It's able to pump out liquid at a high rate, and it's wild. Additionally, they're now toting the fact it is a 45-mile-per-hour max speed. And I know I joked about the whopping 56 pounds of takeoff weight for that MG1. We're now up to 370 pounds of max takeoff weight with the T100. Again, seeing this just 10 years later, the amount of innovations that we've seen arguably is exponential. We're seeing huge leaps and bounds in this area, both from the technologies that they're starting to integrate into these systems, the various control systems, their battery technologies, things like that. We are getting so much better in this space. And it's really exciting to kind of be in this area to get to see where it's going and what's going on with it. So, first off, of course, anytime we're going to talk about drones, we have to bring up the legal checklist. We have to talk about making sure you are compliant when you're making these applications. Because, of course, that is a big thing in any kind of application, both from ground perspective and aerially. So, first off, anybody who's flying even the small drones commercially, you're going to need that Part 107, that remote pilot certification. So you will need that. However, if you're now going to be doing these large UAS platforms, if you're going to be making these drone applications, you're going to need that 44807 exemption. This is just exempting you from certain legal parts of what would be applied to a manned aircraft. Of course, we all understand our drones don't have things like seat belts. That's always a funny point to joke about. But yeah, we have to write an exemption and put that in writing about the fact that, yes, we need an exemption because we don't have seat belts. So keep that in mind. You will then also need that Part 137. So it says that ag aircraft operation. So again, this is going to allow you to make these applications from the air. Okay, so you need that Part 107 and Part 137. You would then also need either an aerial commercial or private pesticide applicator license or certification. Again, contact IDOLs for more information. They are fantastic with this information out there. Again, you kind of have that QR code, scan that with your phone, or go to their website, look for more information. Because again, they're going to be the governing body here in Iowa over that. So, and again, depending upon what you're making or where you're making these applications is going to determine whether you need that commercial or private certifications. Keep that in mind. As well as you're going to need to register that spray drone and get that in number and then make sure that's put on your drone. Again, you have that QR code there, snap a photo of that to go back to it if you need to. Again, you're going to have to do that. It's just the same process as if you're going to the DMV, registering your car, needing to get a license plate. It's almost the exact same process of that you need to register your spray drone and get that in number for that platform. So I do love to tote it, though. I'm, of course, partial to the Cardinal and Gold now that I'm here at Iowa State. So I think this graphic would look much better in Cardinal and Gold. But our friends over at Purdue University did a fantastic job with this visualization. We just got this the other day, or I just was showed this the other day. So I had to include it in this episode today for you guys. Because, again, I think it's a fantastic workflow, something to think as you're going along. It says, are you a farmer applying pesticides to your property only, or are you applying pesticides for hire? And again, it's kind of giving you that workflow. And I kind of put that asterisk down there at the bottom where they reference OISC's requirements. Those are very similar to IDOL's. However, we understand that there are a few nuances and some differences between those two regulatory agencies, between the states. So, of course, if you're applying here in Iowa, make sure you understand IDOL's requirements prior to making applications. Of course, we're going to talk to Purdue about if it's okay if we use some of their visualizations in this workflow, but we adapt it over to Iowa here very soon. So be on the lookout for that. We'll make sure we update this. But again, I think this is a fantastic workflow. They did a great job at this. Again, just kind of hopefully breaking down, again, that kind of legal checklist of what am I doing, both from a pilot standpoint, a mixer loader, and or a visual observer, and what do each of those people need to be compliant? Because I think that's a big thing more and more, especially as we'll kind of hear a little bit later today about the fact that we have a lot of probably newer pilots, a lot of newer operations coming online. Making sure you are compliant is a big deal. As well as, let's now dive into kind of, we talked about the actual presentation, name of this presentation is kind of the best practices. So what are the pieces of a quality application? What makes up a quality application? So the first one being speed. How fast is too fast? I actually made the joke just the other day about the fact I drive a RAV4. And my RAV4, the speed limit, the speedometer on that RAV4 tells me, man, it could go, it goes up to like 160 or 170. Let's all be honest. We understand the RAV4s. At 170, I don't know. I would know for a fact I would not feel comfortable in a RAV4 doing 170. So how fast is this? Just a good joke. How fast is too fast for these spray drones? We understand, like just a few slides ago, DJI said the T100 can go 45 miles per hour max, which is huge from an efficiency standpoint. But is that too fast to be making these applications? How does that level of speed start to affect and compound with the other parameters, the other dynamics of this application? Again, we understand that yes, it's still sharing the airspaces as manned aircrafts. However, these systems are vastly different at how they're going about putting that chemical out onto those crops as opposed to an actual manned aircraft. So again, we're kind of starting to begin to thresh this out. And I know a number of different universities and organizations are beginning to try to work in this space, us included at Iowa State and Digital Ag in particular, trying to thresh out how fast is too fast. Swath. Of course, a big part of this proponent is effective swath. I put that there at the bottom for sure, because we understand, again, just because Toyota says, on the speedometer, 170 in that RAV4, what is his actual effective speed? What's it, when do I get the best miles per gallon? If I'm in a truck, where do I get the best performance for towing? Things like that. What is that effective swath width for that drone? Because though our manufacturers are going out saying we can have a swath width of 40, 50 foot, is that truly effective from a coverage standpoint? Sometimes, I hate to say it, I probably would argue no. Sometimes I think our effective swath, where we're actually starting to understand the overlap between those pass to passes, it's probably going to be a little bit tighter as we're really, we're especially the big name of the game, and we'll kind of talk about it here in a minute, is coverage, making sure we're getting effective coverage. Next, I say HAC, height above crop. As we understand, that is then going to also affect both things like droplet uniformity, understanding, as well as if we start to pick that drone up a little bit higher above the canopy. First off, of course, there are certain requirements on various labels as to how high you can be making those applications at. So, of course, label is law. We'll cover that here in just a second. Label is always law. Keep that in mind. However, some of those other, some of the other chemicals out there are a little bit looser on what that height above crop looks like or what those applications need to be made at. So picking them up a little bit sometimes it can help when it comes to distribution of those droplets, allowing a little bit more uniformity. As we understand, it's able to fall a little bit longer, mixing of those droplets and able to spread out a little bit more. However, again, there is going to be a point of diminishing return if you pick that up too high sometimes, for sure. Gravity inevitably will take those small droplets and bring them down. So trying to find where is that sweet spot, again, always, of course, following the label. And see, I teed myself right up for this at the fact of course, a piece of a quality application is those labeled rates and carrier volumes. Some of these, a lot of these chemicals out there, a variety of different, if this, we're talking insecticides, fungicides, herbicides, whatever it may be, of course, there is going to be labeled rates for that. So, of course, we always recommend following those rates and those carrier volumes that some of them require. Again, a lot of folks right now are currently making those 2 gallon per acre carrier volume rates. We have heard some people whispering about lower rates than that. However, of course, at the moment, wouldn't highly recommend that just due to the fact of, again, coverage. We understand that those drones are not putting out nearly as much carrier volume as our ground sprayers. So understanding, yes, you are able to go over those crops with, potentially, less volume, but at what cost? So be on the lookout. We're doing some work on this, starting to thresh it out as we have heard some interest in that. We've had some people questioning that. However, again, highly recommending making sure you're getting an effective coverage is, of course, making sure you're doing a good job is the ultimate thing you need to think about. As well as, again, modes of action, depending upon what style of chemical, what chemistry is going in the tank, that's something you need to keep in mind. Is this a systemic? Is this a contact? What are we looking for here? This past year with like the Southern Rust, I think coverage was the name of the game. If you got effective coverage, you probably did okay. Whereas, some of those times understanding maybe some folks were going a little too fast, maybe they picked the drone up a little too high, maybe they had those carrier rates a little too low, things like that, just didn't allow those chemicals to be as effective. So something, all these pieces, then of course, you got to love the animations come together to make a quality application. So just wanted to kind of get you all to think of that space going forward of what makes a quality application. As well as, again, of course, there's also other pieces to this that are uncontrollable pieces. Things like, again, wind, temperature, and rain, Mother Nature, as well as operator error are going to be parts of a quality application that we must develop systems to either prevent or overcome. Of course, going out, knowing what your weather looks like, beginning to plan accordingly, okay, what does your rain fast period look like? What do the wind trends going to look like? Again, understanding when is it time to stop. I know we all want to get out there. I know we all want to make sure we get to that next field. We have a checklist each day, but understanding when is a appropriate time to stop sometimes, of course, is a big deal, as well as operator error. We don't want to get too comfortable out there and sometimes be getting lax with some of our systems that we've put in place to, again, try to overcome and prevent some of these errors. Again, so building in potentially some system redundancies, some things, some checklists for you to think about are a big, big deal to try to prevent some of these errors going forward. So I talked about a little bit of earlier about rotary atomizers versus hydraulic nozzles. So largely, for the most part, these rotary atomizers are the most popular method for liquid payload dispersion for these drone platforms. So as we kind of see that, like it says, those atomizers work by introducing the solution to a rotating cup that uses centrifugal forces to disperse said solution. And we understand that there are currently no real standards in place as to styles, methods, RPMs, things like that. So each manufacturer is going to kind of have their own little tweak to that. Of course, that is how the market usually works when it comes to a lot of these. Everybody has their own little tweaks. However, again, sometimes it leads to a little bit of confusion. It leads to a little bit of maybe some miscommunication sometimes, as some brands have droplet coarseness selectors while others allow manipulation of atomizer RPMs, things like that. As well as we highly then, of course, recommend independent testing to validate these droplet sizing. Take your drones out, do your own testing on your drone. Understand what your platform's limitations are, as well as potentially, if you don't have that opportunity, look to organizations like Iowa State, other extension organizations around the country who are starting to develop these repositories of information for you guys. Again, look out there for those unbiased sources for information. We're trying to go out as much as we can each season and develop as much information for you guys to make these quality applications. So, of course, be familiar with your drone. Don't just go buy a drone, put it on a trailer, put it in your truck, and it's like, yep, let's send it. Let's go to the field. Take the time to understand your platform. Because again, like we all understand, nobody is an expert day one. So you go out there, I know I always make this joke about the fact of, when you were 16 or 15, whatever it may be in your state, when you get in that car for the first time, it's kind of terrifying. There's a lot of buttons, there's a lot of switches, there's a lot of knobs, things that you need to control and look at and think about when you're driving that car. You would never get in a race car, with no experience before and go take it and rip it around a track. So the same thing with these drones. Spend the time before the season starts. Make sure you're familiar with your platform, whatever it may be. As well as I like to call 2025 the perfect storm. I really and honestly do think it was the perfect storm, both from a good and a bad perspective sometimes. So what did it look like? We did see a lot of striping that was noticed this year, and it was connected somewhat to these drone applications. We see pictures like you see there on the screen right now, where we saw areas where likely coverage was not effective. This was some kind of drifting issue, this was some kind of swath width issue, this was a speed problem, a chemistry problem. Again, we're trying to connect the dots as much as we can. However, we did see a number of images like this. I know it was all over social media. Doug and I here at Digital Ag got some of these pictures and saw them ourselves as well. So we get it. And for that, I kind of joke about, I think there's likely three major causes to this, to be honest with you, especially here in Iowa. First off, being historic southern rust levels. As you've all probably heard it in my voice a little bit, I'm not exactly from Iowa. I'm actually from the Southeast, from South Carolina, and I did some of my graduate work in Georgia. So some of these southern rust levels, I'm like, hey, this is what we deal with every year sometimes. However, again, here in Iowa, this was historic. This was a big deal. I know I had to kind of recenter myself and again ask people here in Iowa when I moved here in August, like, is this normal? What is, where does this sit on your scale of the level of southern rust? And obviously, as we all understand, it was high. This was arguably an outlier. So we understand that that was, of course, there. The pest was here and a lot of it. Honestly, I also argue we probably had some inexperienced pilots. We had some folks who, arguably speaking, when it comes down to getting into custom applications, $100,000 or so will get you a pretty nice setup when it comes to a drone business. That'll get you maybe potentially a drone or two. That's going to get you a trailer potentially. That's going to get you some mixers, generators, things like that. That's going to get you out and spraying. Whereas, $100,000 is not going to buy you much when it comes to a large ground sprayer. So understanding that buy-in is cheaper, and I think we had some inexperienced pilots this year. Again, not everybody goes in and is able to drive around the tracks day one when you first got in those cars. As well as, again, I point at that operator error. Again, I think there was some misinformation out there. I think there was some misunderstandings potentially out there when it came to what are the limits of these platforms, where are their usable limits at. But of course, I don't want to be, Dr. Doom up here. It's not all doom and gloom because for every striping image we saw, there were many successful fields that were sprayed using spray drones. Again, we have a lot of either farmers that have their own or custom applicators who are going across tens of thousands of acres this past year, especially here in Iowa. And they did a good job, which is awesome. We're so excited to see this new technology blooming and coming out in the market again, adding additional options for our growers going forward. So again, not all doom and gloom, but understanding there is areas for improvement. So, what are we doing at Digital Ag? What are we doing at Iowa State to understand this? We kind of have two major testing methods currently where we're doing one, which is our initial single pass test setup. So, this is just on fallow ground. Of course, understanding that fallow ground and especially like a late season corn are going to react very differently. You'll understand. We'll talk about that here at the end. However, this initial test is again just trying to get some base information out there. So we lay four 12-foot boards out and use them to hold a receipt style paper, as you can kind of see there at the bottom. And we have then three replications of those boards throughout that spray swath. Again, setting 24 foot of swath on each side of that drone pass, trying to get even some potential drift if that's out there, making these applications at 2 gallons per acre. And we're able to then go put in blue dye into that tank. And as you can see again in that picture down there, you can begin to see what does that coverage look like across that swath. So we did this test initially with a Talos T60. Again, as it says, it had a 13-gallon tank and a max swath width of an advertised max swath width of 36 foot. So this is kind of an example of what that looked like. This was actually our Helio drone. So, of course, that application, that was just used for a visualization of what that test looked like. Of course, we make sure that drone is at a steady state as it's going across those boards. We then collect all those papers, tape them together end to end, and then analyze them using a swath gobbler. So this machine, as it says, isolates and reports coverage area of the blue dye across that provided swath. This is actually the same exact method how we test ground sprayers sometimes, understanding coverage. So again, we're adapting some of these testing methods because again, there's really no standard testing method yet out there for these drone platforms. There's work being done in that area. However, we're taking these stabs at what is the best way to do this. And this was kind of our initial test at it. Again, replications were then averaged and graphs of the swath lists were generated. So what does that then look like? What did we start to see with this test? So we initially tested height. As you can see, applications made at 10, 15, and 20 feet above the soil surface. And we begin to see an interesting trend. We begin to see as we walked that height up and up, we begin to see that center of that swath shift over. Of course, there actually was a reason for this. And again, sometimes even what we may call sometimes bad data gives us good examples. Because again, that day we had 10 to 12 mile per hour winds. Again, starting to get way too high when it comes to that wind speed, and really starting to walk that swath away as we started to raise that drone up. And that then causes shifts between 3 to 8 feet off of center. Of course, understanding if we're especially shifting as far as 8 foot off center of our planned swath or our planned AB line, that's a big deal. That's definitely going to start to lead potentially to some of those striping problems. As well as we varied the speed from there, as it says 10, 15, 20, and then the model max, which was around 30 miles an hour. And we quickly begin to see this trend that as we sped up, there was a certain point of diminishing return of speeds, and we greatly started to reduce coverage. Again, understanding that the coverage percentage when these drones comparative to our ground sprayers is already lower. So walking that coverage potentially down as far as 77%, that's really going to limit our coverage potential there and potentially really cause some problems. So the next style testing that we cited after we did that initial setup, we're like, okay, maybe we want to start to look at something that mimics an actual field. How do we test this drone in a field scenario? So we decided to mimic multiple passes of a drone through a field, as it says, measuring the overlap between each pass. So we set the controller up to make 3 continuous passes. So again, it was a down, back, and down. So we did that, and we tested some variables against a few drones. It says that Revolution drone I-19 as well as a DJI T50 were tested with this method. So with that being said, we're going to dive into that I-19. What did that look like as we varied that swath, taking it again down, back, and down? And we begin to see, as that red line shows, that's what our swath, that was where our passes were made. With that being said, we begin to see that coverage. An interesting graph, and here we're going to vary this. It says swath varied by 5 foot increments, but just for time's sake, we're going to look at the 10-foot trends along the way. So this was 20. We then have 30. Again, kind of an interesting spike there at the very end. However, especially across that major part of the swath, we begin to see that coverage level off. 40 foot, we then begin to start to see some of those dips. We start to see some of those problems with the swath where we begin to see that W, maybe indicating, hey, this is where our swath is starting to maybe break down. And then once we walk it all the way up to 50 foot, really starting to see those large W's again, those really dramatic dips in coverage, highlighting probably the fact of, hey, this is well above our effective swath width. We need to back that down some. As well as then we decide to go with that DJI T50 and do some things like height. As we begin to see here, our swath width was set at 28 foot. We begin to see an interesting trend actually with this. Again, as we raised that drone up, we didn't have nearly as much wind that day. We begin to see that uniformity of coverage really start to flatten out as we pick that drone up more and more. Again, that makes sense, of course, because it's giving those droplets more time to disperse as it goes down because it's higher up in the air. Again, however, you need to make sure you're checking those labels for what that height above canopy looks like, if there are requirements there. And again, understanding, as we saw earlier, as we pick these drones up higher, they are more susceptible to things like wind picking up and drifting that chemical off. As well as we ended up going through and looking at speed, again, ranging it just from 15 to 20 to 22 miles per hour. We, again, as we picked that speed up, we saw some reductions there in our coverage. However, not nearly as much when it comes to this time when we did some testing, not going all the way up to that 30 miles per hour or so. As well as we had that swath set at 28 foot, we begin to, again, see some of those dips in coverage, again, maybe highlighting the fact of, hey, maybe 28 foot's a little too wide for this swath. Maybe we need to tighten that up just a little bit more to try to get more of that, again, uniform coverage across that swath. As well as we ended up going out with adjuvants versus no adjuvants when it came to that T50. We really didn't see any effects here when it came to just water and dye. However, one of the things we're going to test this year, as we'll cover here in a minute, is the fact we want to put in some live chemistry. As we understand the viscosity of that liquid whenever you put chemicals in there, it definitely is going to vary when you compare it to just water. Next, some of our friends also of the University of Missouri did a great study. Again, you can see that source there with that link there at the bottom right, where they compared a variety of different parameters when it came to height and speeds and then carrier volumes. And what did that coverage then look like on this ChromaCoat paper? So this is kind of a leading industry standard when it comes to our, especially ground sprayers. It doesn't allow as much bleeding, and you begin to see a really nice view of what that swath looks like as they both change all of those parameters around, as well as they decided to go in and compare that UAV versus a ground sprayer to again show what does that coverage look like? What does that coverage difference look like between these two platforms using that DJI T40 and that ground sprayer? We of course see, ground sprayers are putting out significantly more volume. They are generating much more coverage. Again, comparing a 2 gallon per acre versus maybe a 15 gallon per acre rate, it just makes sense. However, again, what does your application need is what you need to start to think about when it comes to these differences in coverage. Some future testing that we're looking at here at Iowa State is expanding our swath testing to other makes and models of drones to, again, understand the performance of other spray drone platforms and how they vary. Because, again, a lot of these, they look a little similar. However, there's some nuances that change between each model, as well as we want to implement a fungicide comparison test between a standard ground sprayer and a drone. As we understand, as our friends at the Missouri did with that, they were just spraying water. However, we want to see what does live chemistry look like? What does that affect when it comes to coverage at various levels, as well as various orientations within a corn canopy, as well as understanding the efficacy of that application? Because again, yes, we want to get coverage, but then ultimately, how good of a job does that chemical do when there's a problem in the field? As well as, again, we want to further thresh out how adjuvants affect spray swath of a drone given the current rotary atomizers. Understanding how do those affect those, just again, a different style of applications being made. As well as, of course, we love to put a plug in for our friends at the IAAA, the Iowa Agricultural Aviation Administration, so that, as it says, they coordinate and generally direct the efforts of agricultural aviation industry in the state of Iowa. They have their yearly it's usually, it says, manned aircraft members participate in a fly-in day to calibrate their aircrafts. That's going to be June 2nd through 3rd. However, this past year, Digital Ag was the very first spray drone to attend this event. We talked to our friends there, and they allowed us to bring our Helio Ag 230 down to test it on the same exact string method that they do these manned aircrafts. And they've opened that up this year. So I want you to think about that. If you want to go out and try to understand your effective swath width, this is a fantastic method. Look into it. They are very, very good at what they do. A few examples of this, looking at this video. Oh, it's so cool. I'd love to see this. Again, they fly those planes over with that dye in the tank and they have that string pulled across that swath. Then we have our little bit slower Helio going over that string this past year. I know, not nearly as fast as the planes do. Again, though, we were excited to kind of be on the forefront of leading this effort to do some of this testing. So, what does that then look like? You get data back like this. Again, this is the same exact data that they give to manned aircrafts to understand their swaths, as well as you get something like this, where they're again indicating you what is that effective swath across it. So they indicated for our Helio, a 24-foot swath was pretty much ideal. That was where we saw the best coverage across that swath, and that was where they recommended it. So with that being said, think about that in your operation, taking some of your drones down to look into some of this testing. They do a fantastic job. And just want to thank you all for your time today. Again, there's my contact information if you have any questions. Have a great day. Thank you.